Now we are going to read about the helminthic eggs. You may ask a question, why should we know about all those helminthic eggs? The reason is quite simple. The number one reason is that these eggs may be asked as a short answer question or as short notes in the university exams, and you will be able to answer those questions only if you know about those eggs. Na? The second reason is that whenever you are writing the lab diagnosis of any parasitic infection, then you should write the characteristic feature of the eggs of that particular parasite as well, plus you should make a clear diagram also of that egg of that parasite. Okay, otherwise examiner will not give you a good marks. So for fetching a good marks, you should write the characteristic feature and make a diagram, and that will be possible only if you know about those eggs. Na? The third reason is that it may be asked in the OSCE part of the practical microbiological examinations. Like in our college, we used to have a OSCE table where the examiners used to focus the slides of the eggs of the helminths, and we have to go to that table one by one and identify that parasitic egg and answer the respective questions after that. So these are the three main reasons you should know about these helminthic eggs. Okay, so this is quite tough to know about all those helminthic eggs separately, so I have simplified all those in 6 points only. So we will discuss all the eggs in that 6 points only. Those 6 points are: whether the egg is bile stand or not, with what is the size of the egg, what is the shape of the egg, then what is some characteristic feature about the egg cell, plus what is the content of that egg, and then whether the egg floats or not on the saturated salt solution. So these are the 6 points in which we are going to describe all the helminthic eggs, and it will be simple for you as well as it has become for me as well. So now let's start with the helminthic eggs. Okay, first of all, we'll talk about the fertilized eggs of the Ascaris lumbricoids. So first see the diagram of the fertilized egg of the Ascaris lumbricoids. If you see the diagram, the shape looks like oval. The shape is oval. So see, I have written here also that the shape of the helminthic egg is oval, or sometimes it is also referred to as round. Sometimes it is also referred to as round. Okay, then come to the egg cell. So egg cell is thick. If you see the diagram, you will be able to appreciate the thick egg cell. You will be able to appreciate the thick egg cell. See here, this is whole thick egg cell. This is the whole thick egg cell. So it is thick egg cell with outer albuminous coat. So this wavy part over the egg, wavy part over the egg is nothing but the outer albuminous coat, is nothing but the outer albuminous coat. Then come to the content wise, it is containing large unsegmented ovum. See here, this is a large unsegmented ovum at the center of the egg. Okay, so this is containing a large unsegmented ovum. Then examiners may ask you, what is one single most important point by which you will be identifying the fertilized egg of the Ascaris lumbricoids? Then you have to answer the crescentic space. The crescentic space on the both the poles of the fertilized egg of Ascaris lumbricoids. So see here, there is a crescentic there is a crescentic space here at one pole, and then there is a crescentic space here at the other pole also. So this crescentic space is the most important identifying feature of the fertilized egg of the Ascaris lumbricoids. If you are seeing the crescentic space, then definitely it is going to be a fertilized egg of the Ascaris lumbricoids. Then, so these are the 3 points you should know from the diagram. So you should practice the diagram of all the helminthic eggs, and by the diagram you will be able to answer these 3 points: the shape, the egg cell, and the content. Now come to the other three things. The other three things are the whether the egg is bile stand or not, what is the size of the egg, and whether the egg floats or not on the saturated salt solution. So these 3 points we will remember by a mnemonic. For the time being, you just remember that the bile salts, the fertilized egg of Ascaris lumbricoid is a bile stand egg, and the size is 17 micrometer into 45 micrometer, and it floats in the saturated solution. At the last of the lecture, we will see a combined mnemonic where we will remember about all the eggs, whether they are bile stand or not, and whether they float or not, and about the size also I have made a mnemonic. So these three things will be we will remember by mnemonics, but these three things, the shape, eggs, and the content, should be remembered by the diagrams. So you should practice those diagrams at your home. Now come to the realistic diagram of the fertilized egg of the Ascaris lumbricoids. So let's see the real diagram, I mean real picture. Sorry, we are going to see the real picture. So see here, this is the our fertilized egg of the Ascaris lumbricoids. So if you see at these at this, let's change the color of the pen. So if you see here, there is a crescentic space, there is a crescentic space like this. Okay, here at the other pole also there is a crescentic space. Okay, so this, as this crescentic space is present, that means it is a fertilized egg of the Ascaris lumbricoids. Then at the center you are able to see the unsegmented ovum at the center. This is a unsegmented ovum at the center. This is the unsegmented ovum at the center. And then on the outside you are able to see this thick albuminous coat, this thick albuminous coat at the outsides. At the outside you are able to see the thick albuminous coat. So this is thick albuminous coat. So by these characteristic features you can identify the eggs of the Ascaris lumbricoids, rather the fertilized eggs of the Ascaris lumbricoids. So here you are able to identify or see the characteristic features of the fertilized eggs of the Ascaris lumbricoids. Let's come to the next eggs of our discussion. So the next egg of discussion is the unfertilized egg of the Ascaris lumbricoid. Unfertilized egg of the Ascaris lumbricoid. So here also let's see those 3 points, that is shape, egg cell and content. So shape of the unfertilized egg of Ascaris lumbricoid is the longer and elliptical. See, it is quite obvious from the diagram also that it is longer and elliptical. Then come to the egg cell, it is thin and irregular coating of albumin is present. So if you see the diagram, there is wavy, something wavy thing is there on the outer side of the unfertilized egg of the Ascaris. That is nothing but the irregular coating of the albumin. Okay, and that is nothing but the irregular coating of the albumin, which is making the thin cell of the unfertilized egg of Ascaris lumbricoids. Then come to the content. Content is a small atrophied ovum. This is a small atrophied ovum. So these are the three things you should remember from the diagram. Now come to the other three things, that is whether it is bile stand or not. So it is a bile stand egg. Then come to the size. The size is 80 micrometer into 55 micrometer. And then whether it is it floats or not. So it do not float in the saturated salt solution. It do not floats in the saturated salt solution. Saturated salt solution. Now let's see it in the real picture, whether all these features matches or not. So see here, it is longer and elliptical in shape, so one feature matches. Then it has thin coat. See, it has got thin coat, thin albuminous irregular coat. This is thin irregular albuminous coat on the outside. Plus it has atrophied ovum. This is our atrophied ovum. This is our atrophied ovum. So all the features matches here. So it is a unfertilized egg of the Ascaris lumbricoids. It is the unfertilized egg of the Ascaris lumbricoids. Now come to the next one. So the next egg in discussion is the egg of the Trichuris trichiura. Now see the diagram here. How does it look? It looks something like barrel, na? It looks something like barrel. So the shape is barrel shaped. The shape is barrel shaped. The shape is barrel shaped. Then come to the cell. So cell looks thick. This is the cell of the egg. So cell is thick. Okay, cell is thick. So egg cell is thick, and then content is a unsegmented ovum. This hole is the unsegmented ovum. This hole is the unsegmented ovum. So content is unsegmented ovum. These three things complete from the diagram. Now come to the other things. The other things are whether it is bile stand or not. So it is bile stand, and size is 50 micrometer into 25 micrometer. Plus whether it floats or not. So it floats in the saturated salt solution. Now let's see whether these all features matches or not. One thing to note, if someone asks you how are you going to diagnose, I mean how are you going to identify whether it is a egg of the Trichuris trichiura or not. So you should uh, tell the examiner that one most important point to identify the Trichuris trichiura is that two mucus plugs will be present in the egg of the Trichuris trichiura. T4 Trichuris trichiura, T4 2. Okay, so T4 Trichuris, T4 2. So two mucus plugs will be present at two poles of the egg of the Trichuris trichiura. See here, here it is one mucus plug, and here there is second mucus plug. Let's see it in the real picture. How does it look like? So let's see here. there are two mucus plugs. This is one mucus plug and this is other mucus plug, so it is definitely a egg of the Trichuris trichiura. Then you are able to see the thick cell of the Trichuris trichiura on the outside. So this is thick cell, plus there is unsegmented ovum at the center. There is unsegmented ovum at the center, so all features matches. So this is a egg of the Trichuris trichiura. Now next let's go to the our fourth egg under discussion. So that is the egg of the hookworm. Egg of the hookworm. Now see the diagram here and let's answer those three questions: the shape, egg cell, and the content. So shape is oval, as quite evident from the diagram also. It is oval or elliptical. And then egg cell is thin. This, see here, this is a very thin egg cell, very thin pencil thin egg cell is there. So egg cell is very thin, and the content wise it is containing a segmented ovum with four blastomeres. So count here: 1, 2, then 3, and then 4. So there are four blastomeres, and there is a clear space between egg cell and ovum. So there is a clear space also, na. This is quite obvious from the diagram itself. So that's why I am asking you to practice the diagrams at home. This is all the quite, this is all the this is all the clear space. This is the clear space around the blastomeres and in between the egg cell and the blastomere. So this is the clear space. This clear space helps, clear space plus the all the four blastomeres help you in diagnosing the egg of the hookworm or identifying the egg of the hookworm. So whenever someone asks you how are you going to identify a egg of hookworm, so you should tell that there should be hyper segment, I mean sorry, there will be segmented ovum with four blastomeres, plus there will be clear space, there will be clear space surrounding those blastomeres. Let's see the real picture of the egg of the hookworm. Then you will be able to appreciate it better. So see here, there is thin egg cell, there is thin egg cell, plus there is four blastomeres. Four blastomeres, that means a ovum with four segments. A ovum with four segments is there. You will be able to you will be able to count also. This is 1, this is 2, this is 3, and this is 4. So there are four, total four blastomeres, plus if you see carefully, there is a clear space also between the blastomeres and the egg cell. So this is all the clear space. This is the clear space surrounding the blastomere and the egg cell. So this is a egg of the hookworm. So by this you remember the egg of the hookworm also. You will be able to identify, I think. Now come to the egg of the pinworm. Egg of the pinworm. So let's see the diagram. So it is, how does it look like? It looks plano convex. See here, this is plane and this is convex. So it is plano convex. It is plano convex in shape. It is plano convex in shape. Plano convex in shape. Then egg cell is thin. This is a thin egg cell. This is thin egg cell out surrounding the egg. Then content is a coiled tadpole like larva. The content is the coiled tadpole like larva. See here, this is a coiled tadpole like larva. This is coiled, evident from the diagram also that it is coiled. It is coiled, it is, it is coiled and it looks like tadpole. So this is a coiled tadpole like larva in the egg of the pinworm. Now some other points, whether it is bilistant or not. So it is not bilistant. And the size, then size is the 50 micrometer into 30 micrometer. Then whether it floats or not, so it floats in the saturated salt solution. Now let's see and match all the characteristic feature with the real diagram, I mean sorry, the real picture. So see here, this is plano convex, this is the plane, and this is convex side. So this is plano convex in shape, and there is thin coat of the egg, plus the larva is, larva is coiled tadpole like. See here, the larva is coiled tadpole like this. It is coiled. So there is a coiled tadpole like larva, there is thin cell, and there is plano convex shape. The most important feature is the plano convex shape. So by the plano convex shape, you will be able to identify the egg of the pinworm or the Enterobius vermicularis. Okay, now come to the egg of the Taenia species. So eggs of the Taenia species can be identified by characteristic feature of the three pairs of hooklets. By three pairs of hooklets, you will be able to identify the eggs of the Taenia species. So see the diagram. There are three pairs. One pair is here, one pair is here, and the one pair is here. So there are total three pairs of hooklets in the eggs of the Taenia species. Then come to the shape. So shape is spherical. They're quite obvious from the diagram also. The shape is spherical. Then egg cell is thin. This is the outer egg cell which is thin. Okay, so there is thin egg cell. Thin egg cell is there, plus the content is an oncosphere with three pairs of hooklets. So these three pairs of hooklet is the most important identifying feature of the eggs of the Taenia species. Now come to the other three features, that is whether it is bile stand or not. So it is bile stand, and the size is 31 to 43 micrometer, and whether it floats or not. So it does not float in the saturated salt solution. It does not float in the saturated salt solution. Now let's see the real picture of the Taenia egg. So see here, this is the egg of the Taenia species. There is a thin shell outside. This is spherical in shape. Plus there are three hooklets, three pairs of hooklets. See here, this is one pair, this is second pair, and this is third pair. This is clearly seen in the diagram. Now this is clearly seen in the diagram. There are three pairs of the hooklets in the egg of the Taenia species. This is quite obvious from the real picture also. So obviously this is going to be the egg of the Taenia species. Okay, so I think now you are able to identify all the eggs, and you will be write all the characteristic features also. But first let me help you in remembering the whether the eggs are bile stand or not, and whether they float or not. So you can remember those characteristic features by this mnemonic. So non bile stand eggs are the neha. Non bile stand eggs are the neha. So except neha, all others will be bile stand. So what are neha? Neha is Nicator americanus, which is the new world hookworm. Then E for Enterobius vermicularis, which is the pinworm. Then H for Hymenolapis nana, and then A for Ankylostoma duodenal, which is the old world hookworm. So Ankylostoma duodenal is the old world hookworm. Okay. Now come to how are we going to remember whether the egg floats or not in the saturated salt solution. So the mnemonic here is the fateh. So fateh floats on the saturated salt solution. The fateh floats on the saturated salt solution. So what are the meaning of the fateh? Fateh means F for fertilized egg of the Ascaris lumbricoides, then A for Ankylostoma duodenal, which is the old world hookworm, then T for Trichuris trichiura, that floats in the saturated salt solution, then E for Enterobius vermicularis, which is nothing but the pinworm egg. So pinworm egg also floats in the saturated salt solution. Then H for Hymenolapis nana. So the eggs of these organisms float in the saturated salt solution. So by this you remember the bile stand feature plus the floating feature also of all the helminthic eggs. Now the third thing which I had promised to all of you, that I will make you remember the size also, size of the eggs also. So how are we going to remember the size of the eggs? So first write the mnemonic, that is TP. TP, let's see. So it is TP, then TPHFU. Okay, so mnemonic is TPHFU. 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 So T and P size is quite similar. Then the size of the hookworm egg is slightly more. Then size of the the fertilized egg of the Ascaris lumbricoides is more than hookworm. Then unfertilized egg size of the Ascaris lumbricoides is more than the fertilized egg. So how are we going to remember? So just remember the size of the size of this the Trichuris trichiura egg. So the size of the Trichuris trichiura egg was, let's see, the size of the Trichuris trichiura was 50 into 25. 50 into 25. So 50 into 25. 50 into 25. Okay, 50 into 25. The size of the pinworm egg is also quite something around this only. Okay, so I have written equal here. Okay, that's why I have written equal sign here. Then the size of the egg of the hookworm is 10 10 micrometer more than this. 10 micrometer more than this, that means it becomes 60 60 micrometer into 60 micrometer into 35 to 40. So let's write 40. So 60 into 40. So let's see the size of the hookworm egg. We have come to 60 into 40. So here it is quite close. Okay, 65 into 40. 65 into 40 or 60 into 40 is quite close to each other. So that's quite a hack to remember. Simple hack to remember. Okay, then again increase by 10. I again increase by 10 for the fertilized egg of the Ascaris lumbricoid. So 10, right here 10, and then increase by 10. So if we increase by 10, then it becomes 70 into 50. 70 into 50 micrometer for fertilized egg of the Ascaris lumbricoid. Let's see whether it matches or not. 70 into 50. So 70 into 50. See here, 70 into 50. This is quite close. 70 into 45. So 70 into 45 or 70 into 50 is quite close. You can write it in a range of 45 to 50. Okay. So that's also done. Now come to the next egg. So next is the fertilized to unfertilized egg of the Ascaris lumbricoides. Again increase by 10. So here it becomes 80 into 60. 80 into 60 or 80 into 45. I'm sorry, 80 into 50 or 60. So let's see whether it matches or not. So let's see here. So here we see that it is 80 into 55. So there we come to the 80 into 60. So that is quite close now. 80 into 55 to 60 micrometer. Okay. So by this, by just increasing 10 point, you will be able to remember the size of the different eggs also. Size of the different eggs also is also done. You will be able to remember, just remember this trick or this mnemonic, that is TPHFU, and thus in and just go increase the size of the length and the breadth by 10 micrometer each time when you go to the next parasite egg. Okay, now the size of the Taenia species. Size of the Taenia species is uh, I could not make a mnemonic for that, so you have to remember that only. So just remember that the size of the Taenia species egg is the 31 to 43 micrometer. 31 to 43 micrometer. So this is all about the eggs of the helminths. I make you learn about the real pictures of the helminthic eggs also, plus the diagrammatic representation of all the eggs also, so that you can reproduce all those diagrams in your exams and fetch good marks. So that's all for the helminthic eggs. I hope I would have been able to explain about all these helminthic eggs in a simple way. That's all for the helminthic eggs.